The main function of the heart is pumping blood and pushing it flow. How to evaluate this function? We will settle in this class. Cardiac pumping function can be evaluated from three aspects: cardiac output, cardiac work, and cardiac reserve. Stroke volume is the blood volume ejected by each ventricle per beat. It equals the end diastolic volume minus the end systolic volume. At quiet, it's about 60 to 80 milliliter. Minute volume, also called cardiac output, is the blood volume pumped by each ventricle per minute. In normal adults, the average is about 5 liters. Women is about 10% less. Young people are more than old people. In adults, cardiac output can be increased to 25 to 30 liters per minute, 5 to 6 times of normal value, and can be reduced to about 2.5 liters under anesthesia, which is half of normal value. If two men in similar size, cardiac function can be measured by stroke volume and cardiac output. What if in different size? With the same cardiac output, one is tall and the other is short. Whose cardiac function is better? Obviously, in this case, cardiac output is not enough for evaluation. Studies have shown that cardiac output and basal metabolism are proportional to body surface area. The cardiac output per square meter of body surface is called cardiac index. At quiet, it's 3 to 3.5 liters per minute per square meter. Cardiac index changes with different age and state. It's the highest in 10 years old, can reach above 4 liters, and gradually decrease with age to 2 liters in 80 years old. During exercise, cardiac index increasing proportional with the intensity. Does the heart pump all the ventricular blood into the artery every beat? The answer is no. The percentage of stroke volume on ventricular and diastolic volume is called ejection fraction, which is 55 to 65% in healthy adults. At normal, stroke volume change correspondingly with the end diastolic volume, and the ejection fraction means unchanged. In patients with ventricular dysfunction or ventricular enlargement, stroke volume has no difference with that of normal people, but the ventricular and diastolic volume increased, so the ejection fraction reduced significantly. Therefore, compared with stroke volume and cardiac output, ejection fraction plays an important role in early detection of cardiac pumping dysfunction. The activity of each ventricle is the same, but the work or energy consumption is different. Therefore, cardiac work can be used to evaluate the cardiac pumping function. Stroke work is the work done by each heartbeat. This is the formula. From it, we can see that the higher the arterial pressure, the greater the cardiac work. At normal, the cardiac output of each ventricle is the same. But the pressure in pulmonary trunk is only 1/6 of the pressure in aorta. Therefore, the work of right ventricle is only 1/6 of the left ventricle. So, the work of right ventricle is thinner than the left ventricle. Patients with hypertension would accompany with myocardial hypertrophy due to the increase of cardiac work. Some people feel palpitation or short of breath while climbing stairs or exercise slightly. Why? It turns out that their cardiac reserve has declined. The increasing ability of cardiac output is called cardiac reserve. It includes stroke volume reserve and heart rate reserve. And stroke volume reserve includes systolic reserve and diastolic reserve. At rest, the ventricular and diastolic volume is about 145 milliliters. The systolic volume is about 75 milliliters. So, the stroke volume is 70 milliliters. As the normal ventricle can't be expanded excessively, only about 160 milliliters. So, the diastolic reserve is only 15 milliliters. When the heart contracts hard, the ventricular and the systolic volume can be reduced to less than 20 milliliters. So, the systolic reserve can reach 55 milliliters. Therefore, the stroke volume can be doubled, and the systolic reserve is much bigger than the diastolic reserve. In healthy adults, the heart rate at rest is 60 to 100 beats per minute. The increasing ability of heart rate is called heart rate reserve. When the heart rate reaches 160 to 180 beats per minute, cardiac output can be increased to 2 to 2.5 times. However, if heart beats too fast, greater than 180 beats per minute, due to the short diastole and the insufficient ventricular filling, the cardiac output is reduced. In patients with heart failure, the stroke volume decreased. In this case, heart beats faster to ensure cardiac output. That is, the patient has used the heart rate reserve adequate. If do exercise, even if slightly, will feel palpitation and short of breath. Therefore, in patients with heart failure, the heart rate reserve is significantly lower than that of normal people. Let's do a summary. Cardiac pumping function can be measured by ejection volume, cardiac work, and cardiac reserve. In normal middle-sized adults, stroke volume, cardiac output, and ejection fraction can be used, among which ejection fraction is an important indicator for early detection of abnormal cardiac pumping function. Cardiac index is used in people with different size. Arterial pressure is the most important factor affecting cardiac work. In patients with hypertension, the long-term increase in cardiac work will lead to ventricular hypertrophy. Normal adults have a big cardiac reserve. Cardiac output can be increased by 5 to 6 times, while athletes can reach 7 times or more. With cardiac reserve decrease, slight movement can cause palpitation and short of breath. Training can increase cardiac reserve. That's all for this class. Thank you for listening. See you.